everyone, thank you so much for clicking onto this video. Here are today's learning objectives. So first is to look at the use of the terms empirical formula as the simplest whole number ratio of atoms of each element present in a compound, and then the molecular formula, which is the number and type of atoms of each element in a molecule. We're then going to look at calculations of empirical and molecular formulae from composition by mass or percentage compositions by mass and relative molecular mass. And then we're going to look at the terms anhydrous, hydrated, and water of crystallization, and also the calculation of the formula of a hydrated salt from given percentage composition, mass composition, or based on experimental results. So now I'm going to start off by introducing the empirical and molecular formulae. So we need to know both of these definitions because you'll be asked to write these two different formulae. So first we have the empirical formula, and this formula is the one which represents the simplest whole number ratio of all the atoms of each element which are present in one molecule of the compound. However, the molecular formula is the formula which gives the actual number of atoms of each element present in one molecule of the compound. And one really important note is that these two formulae could actually work out to be the same. So for example, if we look at methane, which has the formula CH4, this is also the simplest whole number ratio, so its empirical and molecular formulae are actually both the same. However, if we look at something like hexane, so that's C6H14, if we have C6H14 as molecular formula, we can actually find a smaller whole number ratio. And so its empirical formula would not be the same as its molecular formula this time. And so we would have, if we divided everything by 2, we would have C3H7. So that would be our empirical formula for hexane. And so to convert from empirical and molecular formulae, this is the equation we have. So we have that the number of units of the empirical formula is equal to the MR of the compound, so the relative molecular mass, divided by the relative molecular mass of the compound of the empirical formula, so with that empirical formula. And we're going to see how to use it. So now we're going to go on to finding the empirical and molecular formulae. So we need to know how to work out both of these formulae from data giving composition by mass or percentage by mass. So we have a general method, and the first step is to divide the percentage by masses or the composition by masses, depending on what you get in the question, of all the elements by their corresponding relative atomic masses. And this is basically to find how many moles we have of everything. And then we divide all the values by the smallest value, and this is basically giving us the simplest whole number ratio. So then we use this ratio to find the empirical formula. And if we want to find the molecular formula, we then find the number of units of the empirical formula and then multiply every element in the empirical formula by this unit to find the molecular formula. So in this example, a compound contains 40 grams of carbon, 6.7 grams of hydrogen, and 53.5 grams of oxygen. And it has a relative molecular mass of 60. So then we're told to find the empirical and molecular formulae of this compound. So the first thing I like to do is to write out all of the atoms we have, so all of the elements. So we have carbon, and then hydrogen, and then oxygen. And I always find it quite useful to space them out. So the next thing I do is write out everything that I've got. So I've got 40 grams of carbon, and then 6.7 grams of hydrogen, and 53.5 grams of oxygen. And so this is a composition by mass question. And then, so the first step is to divide by the AR of every single element. So that's our first step. So we have 40.0 over the AR of carbon, which is 12.0. And so this gives us 3.33. And then we have 6.7 over the AR of hydrogen, which is 1.0. And so this gives us 6.7. And then we have 53.5 divided by the AR of oxygen, which is 16.0. And that gives us 3.34. And the next step we have is to divide by the smallest. So the smallest we have is 3.33. So we divide everything by 3.33. So we have 3.33 divided by 3.33, and that equals 1. And then we have 6.7 over 3.33, and this is equal to 2.01. And then we have 3.34 over 3.33, and this gives us 1.00. So it's always a good idea not to round these very much, because sometimes if it's 1.5, that is actually what we take it as. So when we try and find the empirical formula, we will use that 1.5 instead of it being 1 or 2. And then the next step is to find the empirical formula. So first what we do is find the ratio. So the ratio we have is 1 to 2 to 1, because this 2.01 is very, very close to 2. And so that's what we take it as. And so we have that the empirical formula is equal to 1 carbon, and then we have 2 hydrogens, and then an oxygen. So this is our empirical formula. And to find the molecular formula, we then find the units, the unit of the empirical formula, and then multiply this empirical formula by the unit. So the molecular formula they've given us, the molecular mass, is 60. So that's the MR of the compound. So we've got the equation that the unit of the empirical formula is equal to the MR of the compound divided by the MR of the empirical formula. So this CH2 that we've just found. And so the unit is equal to MR, which was 60, divided by the MR of this compound with the empirical formula. So we have the AR of carbon, which is 12, and then added with 2 hydrogens, which is 2.0, and then we have 16 for the oxygen. And so this gives us 2, and so therefore the molecular formula is everything in the empirical formula multiplied by 2. So we have C2H4 and then O2. Now we're going to have a look at calculating formulae of hydrated salts. So first we need to look at 3 definitions. And the first is that anhydrous means a substance which doesn't contain water. And hydrated is the opposite of that. So it's a substance that does contain water. And water of crystallization just means that the water molecules that are present inside crystals. So the example we're going to look at for calculating formulae of hydrated salts is this one. So suppose 6.25 grams of blue hydrated copper 2 sulfate, which has the formula CuSO4 and then an unknown amount of water, was gently heated in a crucible until the mass remaining, so the anhydrous copper sulfate, was a constant 4 grams. Calculate the formula of the hydrated salt. So firstly, because copper sulfate is anhydrous, we know that it doesn't contain any water. And we also know this because when we heat something and the mass becomes constant, that means that there's no more water because it doesn't evaporate, so the mass won't change. And so the first thing we can do is work out the water that we've lost, so the water that's been evaporated. So we have that the water evaporated is equal to the original mass of it minus the mass at the end. So we have 6.25 minus 4.00, which is equal to 2.25 grams. And so we can now use this to look at how many moles we have of the water and of the copper sulfate. So we have the equation moles is equal to the mass over the molecular mass, so the MR. And so now we need to find the MR before we can work out the moles. So to work out MR, we have to add up all of the individual relative atomic masses of the elements in the compound. So we have that the MR of copper sulfate is equal to the AR of copper, which is 63.5, added with the relative atomic mass of sulfur, which is 32.1, and then we have 4 oxygens. So that's 4 times 16. And so this gives us 160. And then we can have a look at the MR of water. So that's equal to 2 times 1.0 plus 16 is equal to 18.0. And now we can have a look at how many moles of each we have in this compound. And so we look at the ratio of this copper sulfate to this water. So we have copper sulfate to water. And so to find the moles of copper sulfate, we divide the mass by the MR. So we have the mass is 4 grams, that was given in the question. And then we divide this by the 160. And then for the water, we have that the mass was 2.25. And then we divide this by the MR of water, which is 18. And so 4 divided by 160 is 0.025. And then the moles of water, we have 0.125. And now we can divide by the smallest. So basically what we're doing is finding the empirical formula. So if we divide by the smallest, we have 0.025 divided by 0.025. So that's equal to 1. And then we have 0.125 divided by 0.025, which is equal to 5. So in the first step, we divided it by the MR. And then for the second step, we divide by the smallest. And so now we have the ratio of copper sulfate to water. So we have that the ratio is equal to 1 to 5. And so we have that the formula is equal to CuSO4 5H2O. So because we haven't been given a molecular mass, this means that this is just the formula of this compound. So it's not just the empirical formula.